Hello, in this video, we show how to convert data to z-scores in R. So z-scores means normalization. So we have a dataset or we have some variables from a data frame. So you may normalize this variable or normalize the dataset so that the mean of normalized data will be 0 and variance will be 1. So in R, we can use scale function. So this can be a vector or a variable from a data frame. But just note, this procedure does not change the distribution of the data to normal distribution. So this procedure just make data transformed to mean with 0 and variance with 1. But the distribution of the data is not being changed, right? May not be normally distributed or may not, but have the same distribution as before, right? So we go to rstudio to read the data frame. So we set the working directory and we create a vector which will represent the variable type of the data frame we will work with, and use rdatacode function to read this CSV file. Then we set the column class as this vector for the variable. Then this data frame called grade. So we show this data frame's information using str function. So you can see 20 observations with 10 variables. And we focus on mathematics, physics, and chemistry scores for students. So first, we will show normal quantile plot for this variable called mathematics. So we use QQ norm for the mathematics variable, and we set a QQ line. So if we look at this, it will may be clear. So this is the quantile plot. Why we do this? Because I want to show after normalization, we have the same normal quantile plot, which means normalization will not change the data structure. Data distribution will not be changed. So this quantile plot with respect to the normal distribution, can see the data is very close to the normal distribution, but except that only one outlier, and this part of points very close to this line. So we just remember this shape for the data before we do normalization. Then we do normalization and we can test Shapiro-Wilk test for these variables normality, because the p-value is 0.83 and test statistic is 0.93. So p-value is not lower than 0.05. So the data can be seen very close to the normal distribution. Then we remember this value. So next we can do normalization using scale function. So scale, grade, mass, and this result set to z mass. So we mean the z mass is normalized data. Then we use QQ norm and QQ line again for the z mass. So you can see after normalization, we have the same data point shape with respect to a normal quantile, right? So the normalization does not modify the data shape. Have the same data structure, and we can also use Shapiro-Wilk test for the z mass. So the test statistic and p-value are the same as before, right? But if we calculate the mean of, say, mass, it will be close to 0, right? And variance of, say, mass 1. But if we do these two original if we do this for the original variable, is 78.9 for the mathematics, and the variance is about 100. So this is the very basics for the normalization. Just note normalization does not change the data structure. It's only moving the data to the 0 mean and shrink the data with variance 1. Thanks for watching.